Hi everyone. Today we're going to study formation of differential equation. A differential equation can be formed by eliminating the arbitrary constants existing in the given solution. If there is only one arbitrary constant in the solution of a differential equation, then the solution should be differentiated only one time, and the resulting differential equation is of order 1. If there are two arbitrary constants in the solution, then the solution should be differentiated 2 times, and the resulting differential equation is of order 2. So, if there are n arbitrary constants in the solution, then the solution must be differentiated only n times. Hence, the differential equation is of order n. Example 1. Find the differential equation from y equals 2 cosine of the quantity mx plus b, where m is the parameter. We can see here that we have two constants. So we're going to differentiate this equation 2 times. Let us differentiate first time with respect to x. So we have dy over dx equals, the derivative of the right side is 2 times the quantity negative sine of mx plus b times derivative of mx plus b, and that is m. When we simplify this, we will write the right side to be negative 2m times sine of the quantity mx plus b. Then we differentiate the second time. The left side is now the second derivative of y with respect to x equals the negative 2m times the derivative of the quantity sine mx plus b, and it becomes cosine of the quantity mx plus b, then multiplied by the derivative of mx plus b, which is m. We simplify further the right side, and it becomes negative 2m squared times cosine of the quantity mx plus b. We can rearrange our right side here into like this, to show that this value 2 times cosine of the quantity mx plus b is equal to our y value, which is in the original equation. It means to say, we can substitute the variable y to this value here. By doing so, it becomes like this. And this is now the final answer, which means second derivative equals negative m squared y. Example 2. Find the differential equation by eliminating the constants a and b from y equals a times e raised to negative x plus b times e raised to negative 3x. We can see here that we have two arbitrary constants. So we will do differentiation 2 times. Let's begin with the first one. We have now y prime, or the first derivative, equals a times e raised to negative x times the derivative of negative x, and that is negative 1, plus b times e raised to negative 3x times the derivative of negative 3x, and that is negative 3. Simplifying the right side, it becomes like this. Let us call this equation equation 1. Let us go now to the second differentiation. So it becomes second derivative equals the negative a times e raised to negative x times derivative of negative x, which is negative 1, minus 3 times b times e raised to negative 3x times derivative of this negative 3x, and that is negative 3. We can simplify the right side into like this. We call this equation to be equation number 2. Next thing to do, let us use elimination method. Let us add equation 1 and equation 2. If we do that, the variable a will be cancelled. So the left side becomes y double prime plus y prime is equal to 6 times b times e raised to negative 3x. This is now equation 3. Next, let us call our original equation here to be equation 0. Let us add equation 1 and equation 0. If we do that, we will have this result. Y prime plus y equals negative 2b times e raised to negative 3x. We observe that the variable a is also eliminated. And we call this equation number 4. Now we want to eliminate the variable b. We say that to eliminate b, let us multiply equation 4 by 3 to get equation 5. After that, we're going to add equation 5 and equation 3. So when we multiply this equation 4 by 3, it becomes like this. 3y prime plus 3y equals negative 6b times e raised to negative 3x. Now let us add equation 3 and equation 5. If we do that, the resulting equation will be y double prime plus 4y prime plus 3y equals 0. This is now the final answer. Example 3. Find the differential equation of the family of curves y squared equals 4cx plus 4c squared, where c is an arbitrary constant. In this example, we have only one constant, that is the c. So we're going to differentiate only one time. So the derivative will be 2y y prime is equal to derivative of 4cx will be 4c. Take note that this 4c squared here is constant, so it becomes 0 when we take derivative. In this equation here, we can simplify further by dividing by 2. So the new equation becomes y times y prime equals 2c. Let us isolate the variable c. So we have this c equals y times y prime over 2. Next thing to do is to substitute the value of c to the original equation. So this equation now becomes y squared equals 4 times the value of c is y times y prime over 2 times the x plus the constant 4 times the square of c, and the c now becomes y times y prime all over 2. Looking in here, we can cancel this 4 with the 2. Then we can simplify our exponent here, and the new equation becomes like this. Look at this expression. There is a constant 4 outside, and we have denominator 4 in here that we can cancel. So the new equation can be simplified into like this. Looking now at this new equation, please observe that there is a common variable, and that is y. We can remove that common variable y. It means to say we can write it to be y equals 2x y prime plus y times the square of y prime. If we want to keep all the variables in one side, the new equation will be like this. 2xy prime plus y times the square of y prime minus y equals 0. This is now the final answer. I hope you learned something from this video. See you again next time.